Now dispersion, which is spread of data, right? So what is the definition of dispersion? So basically two data set can have the same average but different spread. Let's explore why that matters. Now dispersion measures how far data values deviate from the center. Okay, so how it deviate from the center, like mean or median. Now what is the purpose? So it helps in risk assessment, detects outlier, now essential for machine learning model, this kind of thing. Now first is range, the simplest measure of dispersion or spread. Okay, so first range is very basic, which is difference between the highest and lowest value in the dataset. So its formula is maximum minus mean. So in example, so if monthly sales is 50, 100, 150, 200 and 250, then range is 200. Why? Because the highest number is 250 and the lowest number is 50. So it's basically 200, right? So that's the range. Okay. Now coming to variance and standard deviation, the power measures of dispersion. Okay, so what is the formula of variance? Which is sigma square. This is how can we tell them, that is sigma square. Okay, this is sigma and this is square, so it's sigma square. And in a pen and paper you have to write it like sigma and then square. Okay, so this is sigma square, and this is, as I said in the mean section, it is summation. So it is summation x minus mu. Here mu is mean. Okay, so if x denotes the data set, then mu is mean of the data set, and it is also square divided by n. N is total number of value. Okay, so that's the variance formula. Now coming to standard deviation. So standard deviation is nothing but square root of variance. Okay, so it's denoted as sigma, which is square root of, like sigma square is variance and sigma is standard deviation, and square root of variance is standard deviation. Now what is the characteristic of them? So measures how data deviates from the mean, used in risk analysis and performance evaluation, and higher SD is more spread. Okay, so that's the main characteristic, that if you get the higher SD like standard deviation, so that means there is more spread of the data, and if there is lower SD, that means lower spread of the data. Like, so what the spread of the data means? Basically, see, if the data is highly spread, so this is the highly spread, right, this. And if the the distribution of the data is look like this, so this is lower spread, right? See, this is flattered, this is the spread of the data, and this is like lower spread of the data. Okay, so now example, if two classes have the same average score, but no one has scores close together while the other has extreme value, now SD will be higher for the second class. So what did this example mean? Suppose there is two person like 1 and 2. So this person makes the score like 50. Okay, 50, then there is 60, this kind of thing. Okay, 60 and 70. So just take the mean of them. What is the mean of the first person? So just what can you calculate it? So first basically you have to take sum, which is 50 plus 60 plus 70, which is 180, divided by 3, so 60. So the mean of this person is, or this student is 60. Okay, now suppose the second student, who like first he scored 100, then he scores like 50, then he scores 30. Okay, so what is the mean of the second student? It's also 100 plus 50 plus 30, which is 180, divided by 3, it's also 60. So how can you tell that which mean is higher than say first one or second one? Because the mean is same, right? So that's why we have to take the standard deviation. Now, so the SD will be higher for the which class? For this class, because they are for here we taken the first student. Okay, because the he scores the close together, like 50, 60, 70 is close one another, right? But the other has the extreme value, like 100, then 50, then 30, this kind of thing. Okay, so that's the variance and standard deviation, the power of measure. Like, So how can you formulate this variance? So basically just take the difference, like calculation. What can you calculate this way? Like 50 divided minus 60. Okay, minus 60 whole square, this square plus, okay, and then like a 60 minus 60, which is 0, and square is also 0, and then 70 minus 60, which is 10, so its square is 100, right? So basically what's the sum of them? That is 100. This is also 100 plus 0 plus 100, which is 200, right? Now 200 divided by 3, which is like 66, 66, 66 point, also like 66, right? So that means 67. Now calculate the for the second student also. So for the second student, it's 100 minus 60, which is 40. So 40 square, calculate it. So 40 square, then 100, 50 minus 60, which is 10. 10 square is 100 plus 30 minus 60, which is also 30. So it's 30 square. So calculate it, just 200. So its sum is 2600. It is very difficult to write in the this. So please kuch divided by 3, right? So it's 866.6. Point 6. Okay, so that's how we calculate the variance. Okay, now so see what's the difference here. Mean is same for the two student, but the SD is different. Like SD is higher for the second class. Why? Because the other has, that is second student has the extremist value, right? So that's why SD is higher for the second class, and SD is just root under this two values, just root under, right? So that's why. Now next is interquartile range. So interquartile range, what is the definition? So it's IQR, that is interquartile range, measure the spread of the middle 50 of data, reducing quartile effects. Now the formula is Q3 minus Q1. Okay, if Q1 is 20, so what is Q1 and what is Q3? Basically Q1 is, okay, this is the formula. So basically Q1 is first quartile and Q3 is second quartile. So if we divide the data into 4 parts, okay, then just क्या करना होता है इसमें, just very smart way. IQL is a very smart way to measure because it ignore the extreme value. So basically क्या करना होता है, अगर ये तुम्हारा data है, ठीक है, suppose this is the data in this box, just 4 equal part में divide करो, this, this. So now first half, this is 20%. So that range, this is the Q1, that is first quartile, and this is the second quartile, this is third, and this is fourth. So basically Q2 is a median. Okay, so that's a relation between IQR and median. So Q2 is a median, okay, middle value. So if Q1 is 20 and Q3 is 80, then IQR is 60. I will make a detailed video on this quartile also, don't worry about it. So basically now it's a normal measurement of dispersion, so that's the spread of the data. It's also like ignoring the extreme value while focusing on the code data, so that's what interquartile range. And now real life application of descriptive statistics. So where do you use this concept? Basically finance, because after so many theory, we have that one questions in our mind, that why we will learn them, and what is the application of this in the real world, right? So where do you use this concept? Basically finance, that analyzing the stock validity, or then healthcare, that measuring patient recovery times, then marketing, this kind of thing, right? So then coming to a quick like test your knowledge. So what is the best measure of central tendency for skewed data? I have already answered these questions in the video. So if you watch this video carefully, you will definitely answer it. And the second is, what's better for measuring spread, range, or IQR? And why is standard deviation preferred over variance? Because whenever I get an example, there I written that SD is better or higher for second class. Then why I use SD over variance? Okay, so that's a मतलब important task to you. And if you are like तुम statistic honors अगर तुम कर रही हो और करना चाह रही हो, तो तुमको ये सब जानना होगा कि स्टैटिस्टिक में स्टैंडर्ड डेविएशन और वेरिएंस क्यों, मतलब स्टैंडर्ड डेविएशन को प्रेफर मोस्ट क्यों दिया जाता है, ठीक है? बिकॉज देयर्स आर इंपॉर्टेंट लॉजिक ऑन इट. ओके, सो यू हैव टू फाइंड आउट that what's the important logic and what's the important difference of this standard deviation and variance, and how we why we prefer standard deviation over variance, this kind of thing. So that's all for today. So what's next? Basically, so implementation of descriptive measure in a data set using Python. Basically what we have on using Python in our data set, basically we will create a sample data set of like a student's code, this kind of thing, and then we measure like mean, median, and data visualization using different plots, like if that thank you.